Hi, we're going to have a look at the normal distribution now. It's the next topic in the Stats and Mechanics book. So one of the most important things you need to know is that the normal distribution deals with continuous variables. So if you remember last year when we did the binomial distribution, in binomial you could only have integer values. So you could, for instance, say, I am rolling a dice 10 times. How many times am I going to get a 6? And if this was probability against however many times you get a 6, maybe it would look something like this. So you'd have 0, 1, 2, 3, 4, etc. So you'd have the probabilities of getting each different number of 6s. So that was discrete, but the normal distribution is continuous. So instead, you would see something more like this. So if this is my probability, then here we go. So this would be my mean in the middle. This, for instance, could be the heights of people. Let's go for 165 centimeters in the middle. And then out here, maybe we've got something like 180 centimeters. There aren't many people that tall. And then maybe down here, 150 centimeters. There aren't that many people smaller than 150 centimeters. But the reason it's continuous is people could be 150.5, they could be 150.1. And there's a couple important features of this normal distribution curve. So the first one is it's symmetrical. So we've got our mean in the middle here, and the same, half the people are on the left, half the people are on the right. Another important thing is that it's sort of, they call it bell-shaped. So you've got the most people in the middle, and the further away you go, the smaller the probability is that you'll be further away from the mean. We also need to think about the standard deviation. So we know the mean is going to be this point in the middle, well, the standard deviation is going to tell us about roughly how many people are different distances away. So here, if the standard deviation was 5 centimeters, that would mean that between 160 and 170, because it's 5 centimeters either side of the mean, we'd have 68% of our people would be between 160 and 170 centimeters. It would also mean that between 155 and 175 centimeters, we would have 95% of our people. So 95% of people are within 2 standard deviations of the mean. And then within 3 standard deviations, so from 150 to 180 centimeters, that's going to be 99.7% of people. So nearly all people will lie within 3 standard deviations of the mean. So one of the really important things we need to be able to do is find probabilities using our normal distribution. Now you don't need to know a specific formula for this. So if you're interested in the formula, it sort of has an e to the minus x squared term, which is why you end up with this sort of exponential shape on either side, and then a big peak in the middle. So we need to be able to find probabilities. The easiest way to do that is to use our calculators. There's a couple of things we need to know first. We are going to need in our calculators the mean and the standard deviation. If we're given something like this, x follows a normal distribution, this 30, that is the mean, but 16, that is going to be the standard deviation squared. So that means here the mean is 30, but the standard deviation is 4. So they always give you the variance, the square of the standard deviation. So be careful with this. Sometimes they'll just write it as 4 squared. That's fine. You can see it's 4, but if they write 16, you need to square root that. So we're going to put A, B, and C into our calculators. A couple important things to note first. When we're looking at x is less than 33, that's okay. We'll be able to look at all values up to 33, and we can just write 33 as our upper bound. When we say x is above or equal to 24, because the data is continuous, this is the same as saying that x is greater than 24, because because between 24 and 24.0001 there's an infinitesimally small amount of people. So no people are exactly 24 centimeters or are exactly whatever this may be. No people are going to be exactly on 24 because this is continuous data. So it's the same to say greater than or equal to, or just greater than. So the first question we wanted to answer was the probability that x is less than 33. So what we have to do on our calculators, sorry if you don't have the class whiz, but I think most of you have the class whiz. So we need to go menu and distribution. We'll just press 7, and then we want normal CD. We always want normal CD, that's the cumulative distribution, because that tells us the probability that something is less than 33, so adding up all those probabilities. So PD is not really useful to any questions you're going to answer. Then we want the lower and upper bounds, so we wanted less than 33. Now, whenever it says less than 33, I just say, well, I want everything less than 33, so all the way down to negative infinity. So I just write minus a load of 9s, because that's as close as I can do to putting in minus infinity. And the upper bound we said was 33. Standard deviation, I said was 16 or 4. No, sorry, the variance was 4 squared or 16. So the standard deviation we're going to put in is 4. And then the mean, it said was 30. We're going to press equals, and we get 0.7734. Then part B, we wanted the probability that x is greater than or equal to 24. We said that's the same as the probability that x is greater than 24. So press equals to get back to this. Now my lower bound is going to be 24, because I want everything above 24, and I'll go all the way up to infinity, so I'll just put in a load of 9s, so I get a really big number. Same standard deviation, and the same mean, and I get 0.9332. And then the last part of the question that we were going to do was probability that it's between 33.5 and 38.2. So again, equals to go back to my options. This time the lower bound is 33.5, the upper bound is 38.2, standard deviation is still 4, mean is still 30, press equals, and it's 0.1706.